Hello everybody and welcome to your video notes on learning target 3.5 at the meets level. This is Mr. Basil and I'm going to walk you through doing a couple problems. Alright, first off, this one is about the learning target 3.5 is about free fall. And you always have to calculate velocity and distance for your free fall stuff. So it's a little bit more than a typical learning target where you have two different kinds of calculations you have to do. And yeah, so in this video we're just going to focus on the, let's see what color I got going on here, there we go, just on the free fall velocity. And at the meets level, this is going to be when v1 does not equal 0 meters per second. So like in this first example, you can see here that really the 15 meters per second, I got flipped to the other side, but it has a starting velocity of 15 meters per second. So this is going to be exactly the same as the other ones, except we're just going to have to deal with starting velocity this time, unlike before. So, all right, let's get started. And in this one, we're going to be going over this example is going to be A, and the next video I'll be going over part B of this problem. So you throw a penny downward into a well at 15 meters per second and it splashes after 2 seconds. Then how fast is it going? So this tells us we want to know what VF equals. Okay, that's what we're going to be trying to find. Now, one thing that you should note, down is negative for velocity and displacement or distance. Okay, so if you notice here that you throw a penny downward into a well, so this is going to be where we have to start being careful about these things, because if you don't incorporate the negatives, you'll certainly get a wrong problem. We have this equation that we're going to be using. So I think I said VF here. I think for consistency's sake, I'm going to call this V2. VF and V2 mean the same thing. But the equation we're going to be using is V2 equals V1 plus A times T, where V1 is your starting velocity, A is your acceleration due to gravity, which is always going to be negative 9.8 meters per second squared. And then T is our time. Alright, so we want to find V2. So that means that V1 equals A equals T equals, that means we need to know the rest. So V1 is going to be negative 15 meters per second because it's going down. Okay, if they're throwing the penny upwards, then it would be positive 15 meters per second. Acceleration due to gravity is always going to be negative 9.8 meters per second squared when we're dealing with free fall, because that's the acceleration due to gravity. And then T says, okay, right here it says 2 seconds. So 2 seconds. So then we're just going to plug this into our equation. Find my cursor here. Let's see. Oh, how about green? Okay, so this is our givens and unknowns. Now we're going to write out our equation. So our equation is V2 equals V1 plus A times T. Don't need to do any rearranging because it's already set up to solve for V2. Then we're going to substitute. So now we're going to plug in, and let's switch to a different color just because we're cool like that. So V2 equals V1, so negative 15 meters per second. Put that in parentheses just because. And then plus acceleration is negative 9.8 meters per second squared. Erase this over here. Times our time of 2 seconds. Okay, and we're going to think about plugging in our numbers, but first we can see that seconds and the seconds, and then the per second squared, though that crosses out. So 11 meters per second plus meters per second, which is good. And then I guess the last S in guess is solve. So then we're just going to do that now. So negative 9.8 times 2, I got my calculator. It equals negative 19.6 meters per second. Because again, the second's crossed out. And then if I'm adding a negative, that's the same thing as subtracting, right? So just keep that in mind. Okay, so negative 15 minus 19.6. That would be my answer. So there you have it. And this makes sense because it should be going faster, right? So it starts at 15, it should be going faster after 2 seconds. So that's why the number is bigger here. And it should be negative because it's going down. Okay, so what I'd like you to do is to pause this video, jot down, copy down this problem, try doing it, and then come on back because I'm going to be going over this here in about 3 seconds. And I'm just going to be putting the answer up here. So pause, try it on your own. I'm going to be putting the answer on the screen here. Well, right now. Okay, so here's what I got. So I got positive 20 meters per second because the ball's thrown upwards. And then I just plugged in my values and this is what I got. So this is kind of interesting. So it starts going up at 20 meters per second. At the end, it's going down at negative 19.2 meters per second, which is pretty darn close to what I started with. So how does that work? It starts by going up. So this is just for fun because, like, how do I make sense of this? So it goes up at 20 meters per second, but then what ends up happening, it goes up, it slows down, stops, and then comes back down. And if this is where it started, it's probably going to end somewhere right around here. At 19.2 meters per second. If it ended right at the same spot right here, then you would imagine it would be going 20 meters per second, but down. But it did not. That's not what happened. It looks like it's probably close to where it started from. So in the next video, we'll calculate what is this distance that it actually is at. All right, thanks for listening.